And welcome. In the previous concept lecture on projectile motion, we have understood one important thing. These two balls which are identical, if one of these ball is thrown horizontally and the other is dropped, both of them leave their position simultaneously, right, at the same time. This is thrown horizontally and this is just dropped. Then we have seen that both these balls will reach the ground at the same time. This is what we have understood. Now I would like to get into details of this, and we would like to delve deeper into this projectile motion to understand that the horizontal motion of a projectile and its vertical motion can be completely separated and the problems can be solved, right? They are unaffected by each other. And this is what I just said. This ball, this is another ball. There are two balls. These are, let's say they are identical. They have the same mass, although I have not drawn it exactly identical, but they are identical, right? So these are identical ball. This is thrown at some horizontal velocity of 5 meters per second. Thrown horizontally with velocity of 5 meters per second. This ball is just dropped, right? And let's assume that the acceleration due to gravity, that G value is 10 meters per second square, right? So what will happen? This ball will travel a path something like this, let's say, and it reaches the ground. This ball is dropped, so it reaches the ground. And what we have said is that both these balls reach the ground at the same time, right? Both these balls reach the ground at the same time. Now, let's ask a question. What if this ground were here, right? That means this ground, suppose it is here. Will the balls reach this level at the same time? The answer is yes. Okay. Why? Because these two balls reach the ground at the same time. The reason is this ball has initial vertical velocity equal to 0. This ball also has initial vertical velocity, that means vertically downward. Both of them have 0 vertical velocity, right? And both of them are subjected to acceleration, gravitational force of same magnitude. So both of them, as far as their downward motion is considered, they will be traveling the same distance downward in same time. That means the ball will be here, this ball will be here, and this ball will be here at the same time. Okay, so it doesn't matter whether the ground is here or here or here. So this is what we have said. Now let's get into details. For example, let us say that, so we have seen that initial vertical velocity of this ball is 0, right? This is downward velocity of this ball is 0, and same is with this ball. Now let's say, so its initial velocity is 0 after 1 second. Let's say it's after 1 second. What will be its velocity? Because the gravitational acceleration due to gravity is 10 meters per second square, it means the velocity of the ball as it is falling down will increase by 10 meters per second every second, right? So after 1 second, suppose the ball is here, its velocity, the downward velocity, so let's say ball here, its velocity downward will be 10 meters per second, right? It will be 10 meters per second. Let's say that after yet another second, what will be its velocity? Its velocity will be 10 plus 10, because every second velocity is increased by 10 meter per second. So after another second, let's say the ball is here and its velocity will be 10 plus 10, which is 20 meters per second, right? Now what happens to this ball? This ball, which is thrown horizontally, that too after 1 second will be exactly at the same level, right? That means because it is it also has initial vertical velocity of 0, and it's pulled by the same gravitational force. It has same gravitational acceleration, so this ball will also be at the same level. Similarly, we can say this ball, when it has, after 2 seconds, this ball has reached here. After 2 seconds, this ball will also be at the same level. That means it will be here, right? And if you look at the velocities of these balls, so we are considering these two different balls. So vertical velocity of this ball will also be 10 meters per second. It's coming down with the same velocity as this ball. It keeps on increasing. So its vertical velocity will be 10 meters per second. The vertical velocity of this ball will be, here it is 20, so this also will be 20 meters per second. But in addition to vertical velocity, this ball also has horizontal velocity. Horizontal velocity is 5 meters per second, and this will be horizontal velocity of 5 meters per second. So this ball is moving horizontally at the velocity of 5 meters per second, which is undiminished, right? This velocity, downward velocity, keeps on increasing because there is acceleration, there is gravitational pull. However, this ball continues to move at constant horizontal velocity. Why? Because we are neglecting air friction and there is no other force. So this ball horizontal velocity is constant. So this ball is coming here, but its horizontal velocity will be 5 meters per second. Its vertical velocity is 10 meters per second, which increases to 20 meters per second, right? But its horizontal velocity will be 5 meters per second, which remains constant. Horizontal velocity remains constant, right? So so basically, so this is one point. Let's assume now that you are this ball, let's assume a ghost ball. Let's imagine that the horizontal ball which is thrown, the ball which is thrown horizontally, that ball, let's assume that it is not pulled by the gravity, right? So it's an imaginary ball. I mean, every ball will be pulled by the gravity, but let's imagine a ghost ball, an imaginary ball, which is thrown horizontally and it is not affected by gravity. Then after 1 second, where will be this ball? So this ball is going to travel horizontally, right? This ball is going to travel horizontally. After 1 second, where will be this ball? This ball will be exactly above this. Because, why? Because see, horizontal distance traveled by this ball and the imaginary ghost ball, which is unaffected by the gravitational pull, will be always one above the other, right? That's important. So after another 1 second, this ball, I mean, let's say after a certain another time, if this ball is here, this ball will be exactly above this. If the ball is here, this ball will be exactly above this. So this ball which is moving horizontally, it's an imaginary ball. And but it's traveling at constant velocity. Then there will be this ball, because this ball is moving down at the same time moving horizontally. So horizontal displacement or horizontal velocity of this ball and this imaginary ball, which is unaffected by gravity, is exactly same. So you'll always find that they are one above the other, right? Let's get into little detail to make this point clear. Let us consider this is our real ball, right? This is our real ball. So I am just hatching it, a real ball. And imagine two imaginary balls, right? Two imaginary balls. One is this imaginary ball, another is this, right? So I should draw them of the same size. I'll try to do that. But they are all identical, right? Okay, so these are identical balls, right? And this is our real ball, and we have thrown this ball horizontally, right? Horizontally at certain velocity, let's say 5 meters per second. So this is going to be thrown horizontally. This is a real ball. This is an imaginary ball. Imaginary ball in such or a ghost ball, we can say, which is unaffected by gravity, right? So it continues, if it is thrown horizontally, it will continue to move in horizontal direction, and it is thrown at, let's say, 5 meters per second. This is also an imaginary ball which is just dropped. That means its initial velocity, vertical downward velocity is 0. It just dropped. Okay. So it's no horizontal velocity. And this is our real ball. So we have split this real ball into two imaginary balls, and one has got horizontal velocity at 5 meters per second, and the other has initial velocity, vertical velocity downward at 0. That means it just dropped. Okay. So as we have said that after 1 second, suppose this ball is here, right? This ball is here. This ball which is traveling horizontally, let's say this ball in 1 second it will travel a distance of 5 meters. So this is 5 meters, right? And this ball, it started with 0 velocity. This is coming somewhere here, right, in 1 second, because it is starting with 0 velocity and it's accelerating. It's somewhere here. After yet another second, we can say this ball, imaginary ball, is here. Now this is 5 seconds, this is 5 seconds, sorry, 5 meters and 5 meters in 2 seconds. So this ball will be somewhere here, right? Now this is the travel of the two imaginary balls. Where will be this real ball? So after 1 second, if you want to find out the position of this ball, you will have to find out this. This is where the real ball will be. Similarly, the real ball after yet another second will be at the intersection of this. Okay, so this is the real ball traveling like this. So let's say this is, after yet another second, the ball should be somewhere here, right? It will be here. What we are saying is, this is the real ball, path of the real ball. This is a projectile. This path is determined by in an imaginary ball thrown horizontally, which is just moving horizontally, which is not affected by the gravitational pull, and another ball which is just dropped vertically. If you can find their positions, and then these positions will tell you the position of the real ball. So the central point is that a projectile motion can be understood by considering the horizontal motion and vertical motion separately, completely separately, right? So this is what we have said, that every second the ball is here, and every second the real ball will be just below it, right? After every second the real ball is here, so the imaginary ball will be also here at the same level. Okay, so this is what we have said. Now what we are going to do now, based on our understanding, the next video will tell you the two types of problems which are frequently asked. Okay, thank you.